Good morning, bonjour. So today I want to talk about trees, but not these kind of boring, abstract, dead trees. No more, I want to talk about living trees. Now, I'm well aware you're all programmers, so you might not be that aware anymore what trees are. So I can tell you, those things on the left over there for you, those are fake. Those aren't real trees. Now, if you want to remember again what living trees are, you can, for example, watch Lord of the Rings again. They have real trees in there. But also you can walk around in Paris. There are pretty cool trees around. Anyway, one warning about trees. If you eat from the wrong one, then you might die. So be warned. But actually we will discover that that is a feature. So last year people talked a lot about Redux or MobX. And as author of MobX, I can only say one thing about it. Logically true. Yes. Good idea. There is a little more to say about it, and that's what Preeti did. She gave a talk about MobX versus Redux, comparing the opposing paradigms. So I think that kind of settled the matter. And since we learned yesterday that JS fatigue is a good thing, it's time to confuse you again. So what if we tried to combine the opposing paradigms? What will get us that? So I started experimenting together with the MobX community, and out of that came the mobx-state-tree. Unlike MobX, it's a very opinionated way of working with data, so it has an architecture built into it. It tells you how to do everything, instead of just you have observables and things that react to it. So the idea is that it tries to combine the best of both paradigms. It tries to combine the best ideas and the best practices from the community, put it in one package, and then hopefully get you to the best productivity. That's what we're trying to get to. So let's talk a bit about what we know so far about state management. So on one hand, you have this idea, the more classic approach, of mutable model graphs. So all kinds of data can be related to other kinds of data, and I call it models because it's often classes or objects or prototypes, but something that allows you to co-locate your data with your actions. And that is pretty convenient to work with, it's discoverable, and it's super straightforward to modify things around. However, the downside is you lack all historical information on what is happening. On the other hand, we have this idea of immutable data trees. So our state is just a tree of data. It doesn't modify anymore, but our store in the future will just point to another tree. And you're all familiar, I think, with this idea, but this gets you things like time traveling and historical information. And both approaches have their own advantages. So with model graphs, it's easy to discover your functionality. It's straightforward to write actions. But you don't have cheap snapshots, and you don't have this structural sharing. So we are going to dive in this list a bit deeper. But first I want to talk about snapshots. I think we all agree that having a snapshot of your data is awesome. And snapshots are awesome like texts are awesome. I like the idea, I like where they get me. They get me roads, they get me healthcare, except if you're from the States, but that's a detail. But I don't like paying taxes. So what if we could just, after each mutation, get a snapshot for free? So then we are no longer responsible ourselves of producing a new snapshot in our actions. We just modify some data, and then a snapshot is produced from that. So that is basically the idea behind mobx-state-tree. We have a store, and it is a living tree of data. You can move stuff around, you can change it, but every time you do that, a new snapshot gets produced. So here's a very small bookshop application. It has some books and a card, and people who attended the workshop on Tuesday will recognize it. And what we see is that we have here a record of all the states our application went through. So it started quite empty, and then the data got loaded and the card got loaded. And we have our snapshots. But the important thing about snapshots is that they should have structural sharing, because otherwise it will be way too expensive if your application is running for a long time. Now in the MobX community there is already a best practice how to do that. And that is simply, if you have the concept of a book, you give it a getSnapshot function, which produces an immutable view on that book. And because it uses computer properties, these things get memoized. So the snapshot of a book will only update if either the title or its price changes, and under no other circumstance. And if you then have a store which contains a list of books, then the snapshot of that store is simply mapping over all the books and taking their snapshot. And that gets us structural sharing. Let me show you. So suppose you modify something in this book, then that will produce a new snapshot for that book. And that snapshot will propagate to its store, causing the store to recompute its own snapshot. And it will map over all the to-dos, but for all the to-dos, all the books that didn't change, talked about to-dos so much. Way too many talks about to-dos. Anyway, so for all the other books, the same snapshot will be used. So you have structural sharing. So basically, we can, this way, build a tree, and that every time you change something, captures its essence, its DNA, in a seed, and then we have a new problem. Because we have the seed, but how do you get back to a full tree again, where all the methods are again co-located with the data? And also, how do you avoid all this snapshot boilerplate? Well, let me first demonstrate that we can back to a full tree. So I can simply click on a snapshot, and then my application is back in that state. So this is how our application started when loading. And this is where we are now. So apparently we can restore from snapshots. And how this time traveling works in this specific demo is just these few lines of code. We can listen to all the snapshots happening in the tree, store them, and we can replay them by just applying them back. And the crucial ingredient to be able to do this is type information. And we have been talking about type systems and type information yesterday already. And for most people, type systems mean compile time type checks. That's what they're good for. But they are good for more. They're also very useful for runtime type checks. This is what we do, for example, with React prop types. That's a kind of runtime type checking based on a type system provided in React. But you can also use type information to determine what behavior something should have. So if we know about the type, then we know how to create snapshots. So in mobx-state-tree, every tree consists of basically two things: its state, or its contents, and its shape, or its type. And abstractly speaking, this is how we work with that. So we can declare a type, so we can model an object, and we can declare what its properties will be and what its actions will be. And then we can use a snapshot to instantiate an instance of such a type. And we can invoke some actions, and then we can get simply back to the snapshot again. So we can easily interchange those. So the model of the book in this application, it looks just like this. It has two properties, and it has an action to modify its price. And then the store is just composing the type of a book with the type of an array. And then we have described our store. And because we have this type information, we know how the snapshot should be structured. We know it's an array, so we know that we should map over the children for the snapshot. So we don't have to write it anymore. So from now on, I can just take some JSON data, put it into the store type, and then we have a real store. And I can start invoking actions on it. And even more, because we have all this type information, you can imagine that I try to add new books to this store. But in fact, I don't have to add new books. I can just add new snapshots of books. And the type system knows this is supposed to be a book, so it will create a book. And of course, with all this type information, we can do runtime type checking. So if you make some mistake in your JSON, you get this nice fine-grained error messages back about what was wrong about the structure. So if you in the end decide that mobx-state-tree is useless, then at least you can use it as a JSON validator. But what is really cool, and what still blows my mind, is that with this type system, which is introduced by this library, we can also do design time type checking. So this is a screenshot of Visual Studio Code and my TypeScript test project. And it infers what I do wrong, how I use those models wrong. Now this might at first seem a pretty normal thing to do for TypeScript, but the cool thing is these types are not defined with TypeScript. These types are defined with mobx-state-tree, with the code you just saw. So TypeScript is actually powerful enough nowadays to define a type system in TypeScript and then do checks on it. And it's pretty mind-blowing. You have maybe to dive a bit into it to see how amazing that is. Probably Flow can do this as well. I'm just not enough into Flow, but if somebody wants to make a pull request to add Flow typings, that would be perfect. And this type checking is based on the work of Gio Canti, and he wrote a library, Type Combinators, and Mattia Manzatti, he put that into the mobx-state-tree library. So those guys are actually responsible for a large part of the library. And it's pretty powerful. It has collections, refinement, unions, literals, even recursive types. It can even have types across different files with circular dependencies. So what we've seen so far is that we could combine quite a set of features from both worlds. So we have cheap, structurally shared snapshots. We have a tree structure. We can easily hydrate and dehydrate. We can co-locate our actions. And our actions themselves, they're pretty straightforward to write. We just modify some local data. And we have the static and runtime type checking. But there's more. Because mobx-state-tree is based on MobX, it has this notion of fine-grained observability, where every property in your system is observable. So that means that with mobx-state-tree, you can simply subscribe to the patch stream of your data. So here are all the patches happening in my application. So snapshots I cannot exchange with my server. They're way too big for that. But I can exchange snapshots with the backend to distribute changes. So I can just change something and a new JSON patch gets produced. And I can reapply those patches. So I can also work with JSON patches out of the box. Let's talk a bit more about actions. Actions, as I said, they're pretty straightforward, but they have some special properties. First of all, you cannot modify a state tree without using an action. It will just throw an exception. So if you try to modify something directly, by default, you get this exception. There and there, you're trying to modify your state without using an action. And this is important because if you are forced to use actions to modify state, then we can benefit from replayability. So I can, for example, go to the books and add some book to my cart. And if I look here, then I see that action can also be recorded. And I can go to the cart and you can see that I can just replay this action on my state. So I can replay and record snapshots, I can replay patches, I can replay actions. However, we don't produce any action description anywhere. We don't dispatch any actions. Now in mobx-state-tree it's inversed. You just invoke a method and we produce the action description for you. And you can even intercept that if you want. But that makes it super straightforward to use actions and still be able to replay those things. And a nice use case for replaying actions, one is having different clients working on the same data and synchronizing on actions. But the other one is where you have this complex tree of data and the user starts to edit this data in a wizard. And usually that gets complicated if there's lots of data potential to be edited. But that's simple now as well, because what you can do is you can just take some part of the tree and clone it. And because mobx-state-tree is a fully recursive concept, so every node in our tree is a state tree in itself, and every operation we can invoke on the root, we can invoke on any node, we can just start listening on actions in a specific subtree. So we then clone a book, which is simply taking the type and taking its snapshot to produce a new instance. So we can clone a book, and then we can start an action recorder, which just stores all the actions being invoked, and then the user starts modifying this data in a wizard. And in the end, if he's okay with it, we can just replay those actions onto the original object, and we have this atomic commit of all the changes he made. So with that, we have fine-grained updates, we have protection of data, and we have replayable transactional data. Now, Elrond, that wise guy in the Lord of the Ring movies, he once said, "Death is a gift to man." I'm not sure whether I entirely agree on that statement, but there's some use to it, as you will see. So let's think a very bit about references in JavaScript. So here is a small function that prints the price of a book. The only nasty thing is it prints it 1 second for now. Now, what assumptions can we make on the price that gets printed? Well, it turns out that largely depends on which model you use. What does a reference represent? What does the book reference as argument, what does it represent? It's like asking the questions, is this 4 times the same tree, or are these 4 different trees? It's kind of conceptual. It depends on semantics. So if you use immutable data, then a reference refers to a concept. And that concept might change over time, but you refer to the same concept. On the other hand, with immutable data, you always have a reference to a state of a concept, somewhere in history or in current, but to a very specific state. So if this book is immutable, then we know for sure that 1 second from now, that price won't have changed. The price of that book we passed to that function. With mutable data, well, the price might have changed. The price you print might be different from the one it was when we passed in that book to the function. But with the immutable data, that price might be still. That book with ISBN 123 might have received an update, but that's in a different state tree. And with mutable models, we know for sure that it might have changed, but at least we will be printing the latest price. And what semantics you need depends on what feature you are building. And if I were a consumer of this bookshop, I know what semantics I would need. That is, print the one which is the cheapest. But with mobx-state-tree, you can choose between semantics. So you can give either a reference to this book in the state tree, in which case you refer to the concept, or you can pass a reference to its snapshot, in which case you refer to its state. But we can get it, make it even nastier. So suppose we invoke this print function, and right after that we remove this book from our store. What will be printed? For the immutable case, it doesn't matter. For the mutable case, it will print whatever happens to be the last price known in the system. But if you're using mobx-state-tree, something else will happen. You will get an exception. You will get an exception telling you, hey, you're using some data, you're reading from some data, which is not even in your state tree anymore. So probably the data you are using is coming from some stale reference. So maybe you shouldn't be using this. And you might be thinking, isn't that a kind of rude? But well, it's like if you try to hang up a swing in a tree, then you better make sure that that swing is attached to a living branch, not to a dead one, because otherwise this picture ends very badly. So what mobx-state-tree provides you is not only protection against unintended modification, it even gets you protection against accidentally stale reads from data you were not supposed to be used anymore. So that is why I said sometimes it's a feature when you pluck from the wrong tree and you die based on that. Finally, so far we have just been talking about trees, because trees are easy to traverse, etc. However, not all models of applications fit nicely into trees. Even our bookshop doesn't fit nicely into our tree, because our cart entries refer to books. However, we cannot make a real reference here, because then we would introduce a graph. We would lose our tree semantics. So we have to normalize our data. Do we? In the mobx-state-tree, we have the type information of the shape of the tree you defined. So we can just tell the system, hey, this book in the cart entry, that's not a book itself, it's just a reference to a book. And after that, you can just interact with your cart entry. You can assign real books to it. You can read data from that cart entry and you get a real book back. You can access its data. But behind the scenes, the normalization is done for you. So even though the book entry.book contains a real book, if you print its snapshot, you will see that it's in the background still normalized. It does the reference management for you. So with that, we have a tree with which you can interact as if it's a graph. We can have DevTools, as I showed you in the demo, and we can choose which semantics we need for our references. Either we can refer to a concept, to an identity, or we can refer to a concept in a specific state, whatever we need. But there's something more. So this is the Redux to do MVC application. I'm pretty sure you all once run this thing. And these are the dev tools we're so familiar with. So we can play back and forward in time. You've all seen this. Except there's something weird with this Redux to do MVC application. I removed the reducers file. And after that, I created a new file, and in that I put a mobx-state-tree model of a to-do list. But the rest of the application is the same, and it still works. It has a Redux Connect components, it has action dispatching, it just doesn't have any reducers anymore, it has a state tree. But because a state tree can provide everything we need, snapshots, applying snapshots, action descriptions, replaying actions, we can interchange those two paradigms. That one. So this is what our to-do store now basically look like. Pretty straightforward. We define the shape and we define some actions on top of it. And you see that the action still has a weird uppercase name, but that's because that's the name of the action that gets dispatched. So the names have to match. But that basically proves that we can have a mutable tree and all the features we know from the immutable world. So we can combine the two opposing paradigms. So that's what mobx-state-tree tries to do. And you can already use it. There are actually some people using it in production already. It's not 1.0 yet, because the docs are not completely up to date. But hey, worse is better. So start it, use it, play with it, and last word of advice, hug some tree today. Thanks.